In this video, we will talk about the contingency coefficient and Cramer's V. The phi coefficient works for data in 2 by 2 tables, but what if we have a table that's greater than 2 by 2? For that, we turn to the contingency coefficient and Cramer's V when we want to find associations between variables using nominal data. So let's start with the contingency coefficient. To illustrate how the contingency coefficient works, I will use the following problem from your textbook. A graduate student interested in political sociology comes across research that theorizes that the presence of certain types of natural resources in a region may lead to different forms of political violence. To test this hypothesis, she studies 119 different regions in which intergroup conflict occurs and creates a crosstab that indexes 3 natural resources: oil, diamonds, and coltan, which is a precious mineral used in most major electronic devices, with 3 possible conflict types: ethnic conflict, intrastate conflict, and interstate conflict. Based on the following cross-tabulation, calculate a contingency coefficient and Cramer's V and determine whether they are statistically significant. Okay, so we can do this. As you can see, the data over here are arranged in a 3 by 3 table, which is larger than a 2 by 2, so we're going to not use the phi coefficient, but use the contingency coefficient first. And as with the phi coefficient, the first step in finding a contingency coefficient is to find the chi-square. And voila, with the magic of Excel, I've calculated that chi-square. And you can see at the very bottom, our chi-square for this table is going to be 46.25. So we're going to first see if our chi-square is significant. And to do that, we need our degrees of freedom. And if you will recall, that equals the number of rows. We have 3 minus 1. Times the number of columns, 3 minus 1. You know what this is, but we just walk through it. Okay, so our degrees of freedom are 4, and we're going to look at our table, our chi-square table. And if we look at degrees of freedom of 4 at the 0.05 level, our chi-square needs to exceed 9.488 to be significant at the 0.05 level. So we see that our chi-square definitely does exceed 9.4, whatever that was. And so I'm going to go ahead and put yes, that it is significant at the 0.05 level. And this is important because our Cramer's V and our contingency coefficient are going to use the chi-square significance as significance for their associations as well. Now, to find the degree of association, we're going to compute a contingency coefficient, and the formula for contingency coefficient is right over here. It is equal to the square root of chi-square over n plus chi-square. So let's plug in the numbers into this formula to find our contingency coefficient. You could break down the formula into steps, but I'm going to live on the edge and do it all at once. Square root of the chi-square over, I'm going to put the denominator in parentheses, our n of 119 plus our chi-square oh my. Okay, but it still gave me the right one. I don't know what I did, but it corrected it. And so our contingency coefficient is 0.53. So that is the association between the types of conflict and the resources in a region. So we can say, using the contingency coefficient, that there is a significant positive relationship between natural resources found in a region and type of political violence. So very easy to find. The contingency coefficient has some mathematical drawbacks, however, especially with non-square tables, such as a 2 by 3 table or a 3 by 5 table. So even though our table is a 3 by 3, I'm going to use it to demonstrate how to calculate a Cramer's V. The formula for Cramer's V can be found right over here. It is equal to the square root of chi-square over n times k minus 1. And k in this case means our number of rows or columns, whichever is smaller. And in this case, our number of rows and columns is both 3. And so we're going to use 3 for k. So let's plug in the formula to find Cramer's V. Equals the square root. And I've got the chi-square over, in parentheses, the n times, and I need another parenthesis here, our rows or columns 3 minus 1. Close that. And I'm going to close it again, and I hope I don't get an error. And I didn't. Okay, perfect. So our Cramer's V is going to be 0.44. So this 0.44 again shows a positive association between natural resources found in a region and the type of political violence. And so that's all for our 5 funky measures of nonparametric correlation. Next week, we're going to turn to correlation using interval level data, and that is a type of correlation you're going to see much more out in the wild. Until next week, bring any questions you have to the discussion board.